Hello guys, so I'm back once again, and as we are already continuing this series, the 10 minutes to pandas have gone quite long, but it's been fun so far. Now we are going to have a look at string methods. We are still reading the documentation. Just to remind you all, I'm also a beginner like you are. I haven't done any real world projects. I've just looked at syntax and watched a few crash courses. So I'm reading all this stuff for the first time as well, and most of this is new to me as well because crash courses do not go that in depth. So now, yeah, let's start with string methods. Series is equipped with a set of string processing methods in the str attribute that makes it easy to operate on each element of the array, as in the code snippet below. Note that pattern matching in str generally uses regular expressions. They are also known as regexes as short, if I'm not wrong, by default, and in some cases always uses them. See more at vectorized string methods. We might look at them in some other video. Right now we are focusing on this series. So let's just create this series in our own uh, document. Oh yeah, I forgot to import pandas and stuff. So let me just do that. And now this is ready. As the series S is ready, and just using the string methods, if you're familiar with them in Python, you can do your string dot lower, and it converts it all to lower. So you can see nan remains unchanged because nan is a none value, and that's it. So the string method part is done now. So now let's have a look at merge. So merge has this concat. Pandas provides various facilities for easily combining together series and data frame objects with various kinds of set logic for the indexes and relational algebra functionality in the case of join merge type operations. Okay, merging databases is quite important. Now concatenating pandas objects together with concat. Okay, so they've created two data frames and then use concat on it. Okay, so let's just create this data frame ourselves, and now let's just print out df. So this is our data frame. You might wonder why is it different, because it has random values, rand n. We discussed rand n before. It takes random values from the normal distribution and break it into pieces. So basically pieces is now a list which has different sections of the uh, different sections of the data frame, and now we can just concat pieces. So I guess we input an iterable and it just concats them. So we have now concatenated and recreated our df. Okay, so that's quite simple. Let's read the note. Adding a column to a data frame is relatively fast. However, adding a row requires a copy and may be expensive. We recommend passing a pre-built list of records to the data frame constructor instead of building a data frame by iteratively appending records to see it. See appending to data frame for more. So it's a good thing to keep in mind that computationally adding a row is more expensive as compared to adding a column. So now let's look at join SQL style merges. So SQL, I don't know what's the right way to pronounce it, but I've heard SQL has this command join. I had learned SQL in school like 6 years ago, so I'm not quite sure I remember anything. But let's just look at it. Join, the word itself seems quite explanatory. So they've created a left and a right. So basically, yeah, they have inputted a dictionary where keys and the values, key value pairs are there. So they have created two data frames, left and right, and then yeah, just printed out left and right, and then just merged them. So merging them on key basically means on the key index, because now you can see that the key isn't being repeated twice. We can even do the merge on ival. No, oh, so it needs something which is common. So key is it is. So for the first foo, the key had 1 and it had 4. Okay, so for the first foo, it did something like this. It took the foo, then it took the ival and the corresponding rval, and then it took the ival and the other rval, and so it just created all the combinations. So 2 into 2, 4. Okay, another example, right? So let's have a look at this as well. This has foo and bar. So foo and bar are now different. In the previous example, there was only foo. So now we have created our two tables, and now let's just try to merge them using the same. Okay, yeah. So now there is no scope of repetition. Foo is with foo, bar is with bar. So foo is 1 and 4, bar is 2 and 5. What happens if I remove the key? Let's just try. Okay, so I guess it automatically looks for the common stuff. Maybe if I change the name of all the columns, then what happens? Okay, so it rewrote, I reckon. Yeah, it only took the last value for ival, not the first one. Oh, it's lval, left value. I've been reading it wrong all along. Yeah, so that's it. Now let's look at grouping. Grouping is quite important because when you have a data set, you might want to sort it by the country of the people who had answered, say the survey, or the people who, if it was some survey with their works, you might want to segregate it with their experiences to see how different people's opinion changes over time when they work in an institution and so on. So now let's look at grouping. By group by, we are referring to the process involving one or more of the following steps: splitting the data into groups, applying a function to each group, combining their results into a data structure. Okay, so first of all, let's just copy this stuff. So they've created a new data frame using once again the same foo and bar, foo bar, and so on. np.random gives random values, eight random values. You might just try out 9 maybe. It won't work because the number of columns no longer matches the number of rows, sorry. Now let's just print out df. Okay, so first of all they are doing df.group by a and using the sum. So let's do it in two parts. First of all we have df to look at here. Now let's just do a group by a. So it's created a group by object. Now you need to do something with that group by object, right? So you do a sum. So for bar, it took all the values which have bar and added them, if I'm not wrong. So let's just have a look at it ourselves. And the values were 0.265. Okay, let's just get a rough idea. 0.26, then minus 0.31. We might get some differences, but that's because we're not doing it exactly. Then adding a point 0.6. So bar occurs 1, 2, 3 times. So now we add a point 0.6. And what we get is 0.55, which is different from what we are getting here. Let's just have a look once again. Bar is here, bar is then here, and bar is then here, right? So 0.265, 0.61, 0.265, 107 plus 0.610613, 0.610613, and then we subtract 0.316212, 316212, and we get 0.559 once again. Sorry for the background noise, there's some stuff going on, and it doesn't seem quite right. So what's going wrong exactly? We need to figure that out. Yeah, I'm back now. Let's uh, see what's going wrong here. So group by A, um, grouping and then applying the sum function to the resulting groups. Oh man, I've been comparing it to the wrong stuff. When I do the sum, I'm not supposed to get what they are getting right here. I'm supposed to get the sum according to this, right? So still it doesn't match. They had 1.5 and then a 1.2 and then a minus 9. This calculator is quite a bad deal to use, having to randomly type everything, doing this, then and then adding once again this 1.732 just like what it's here. So what's going wrong in my case? Let's just create df once again, df.group by and df.sum. So let's take the first value, then let's take the second value here, and then let's take the third value, which is this. It should work minus 0.122, same. So I might have been making some mistake earlier, but you can see it works. So it took all the bar values and added them, and took all the foo values and added them for column C and column D, because doing that for column B doesn't make any sense, just strings, right? So now grouping by multiple columns forms a hierarchical index, and again we can apply the the sum function. So first of all, let's do this stuff once again, and let's add a column first of all. Sorry, let's have a look at our data frame, and then okay, I made this mistake. Have it. I need to have it at the very bottom. Yeah, so our data frame is here. Now, first of all, it took like bar and then the corresponding values in for B. So bar had 1, 3, and 2. So 1, 3, and 2. While foo had 1, 2, 2 once again, and then 1 and then 3. So it didn't do them multiple times, rather, it just uh, took all the ones and clubbed them together. So let's just add the foo ones. So foo1 is this value right here, to make sure we are not doing anything wrong. Then foo1 is right here, so it's minus 1.3, just like this here. So sometimes you need to try out stuff, because you might have made the wrong logic, and then it might stick with you for your life, and you might end up making some error in some critical position. So now let's have a look at reshaping. Reshaping, there isn't much given for reshaping, but I think uh, reshaping pandas data frame, I'm not quite sure of what the syntax was for it. Stack Overflow to the rescue as always. Okay, so L reshape and all these, some are undocumented as well. So we'll have a deep look at it once we explore these sections. Now let's look at stack. Yeah, sorry for all these disturbances. There's someone at the door almost every time I start to record. So now let's look at stack, and I didn't copy it. So we have this tuple, and this is a list of all these things, and then run it once. So we have tuples. I am also totally unfamiliar in this territory, so I'm doing my best to explain stuff. If I don't understand something, then it's totally due to my lack of knowledge in this subject. So bar 1, bar 2, bar 1, bash 2. So it's sort of pairing them together. Okay, list zip. So maybe that's what zip does. I haven't used zip much. So next they use an index. So can we print out index? Yeah. So they've pd.multi-index from tuples, and then they've used tuple, inputted the tuple and the name. So basically I reckon it made the names first and second, so it created sort of an index. And then okay, so that's an index value. They are now going to create a data frame out of it. So they've set the index to be this index which they generated, and p.random random 8 to 2 values being taken. Then like this is sort of what they did to generate these data frames earlier. So basically they've taken random values, 8 random values, rand n. So I'm not sure what the 2 is in the input, but I reckon it's something, a parameter which alters the normal distribution. Maybe I could be totally wrong, but that's what I can understand. So now here we have the index, and they set the index to the index. So this index is now here, and this came under first, this went to second, so all the bars were clubbed together, bar 1 2, bars 1 2. Okay, and the column names have been given by us, A and B. um, what happens if we do not provide the column names? It still makes the data frame, so it gives them the standard names, 0 and 1. Okay, so now with that out of a way, they've sliced the data frame to create df2, and let's just print out df2. So what this does is it takes the first four rows, so 1 2 3 and 4. They slice that stuff, and the stack method compresses a level in the data frames columns. Let's try to understand what that means. I haven't used stack ever. So stacked df2 dot stack. Okay, and then let's just try it out ourselves. So yeah, right here, stacked, and what it did was, so bar 1 A and B, 2 A and B. So it sort of shifted those columns here, something along those lines. Com compresses a level in the data frame column. With a stacked data frame or series having a multi-index as the index, the inverse operation of stack is unstack, which by default unstacks the last level. Okay, okay. So here they use multi-index for this reason, most probably because then you can use the unstack function. So when you do stack dot unstack, um, you get what you had, but by default it takes the first level, which in our case was A and B, but they can specify levels as well. So if they do that, then 1 and 2 get unstacked. Level 0 is probably A and B. Yep. What about level 2? Uh, there isn't any level 2, I guess. Yep. So let's keep that at level 1. There seems to be something wrong. So this numbers were, I've never used these many lines in a Jupyter notebook before. So at 155, then it started at 3. Okay, they are in the order of being run. So 57 and 58 because all of them hadn't been run earlier. Okay. So now let's unstack 0. creates bar and bars, sends bar and bars there. Did that do unstack? What about unstack 2? Unstack 2 sends A and B. Okay, so that's it. Uh, Now we are nearing towards the end. Let's just do pivot tables as well. Pivot tables, pandas.data frame, again a dictionary, and created the data frame, printed out the data frame, the standard stuff. We've been doing this for quite a while now. We can produce pivot tables from this data very easily. I'm not sure what a pivot table even is. So I might just um, look that up. What is a pivot table? A pivot table is a table of statistics that summarizes the data of a more extensive table. This summary might include, okay, so basically a brief outline, a brief summary of a larger table is being provided by the pivot table. Okay, so pt.pivot table, df, values d, index ab, column c. Okay, we'll try to figure that out, what all that stuff means. So we have a data frame here. So ab indexes, column C is here, C, bar and foo. Bar and foo remain okay. So 1A, um, this is quite confusing right now. Let's try to understand what they're trying to say. The documentation shouldn't be too difficult, otherwise, no one would recommend reading the documentation. A, here we have 1. So let's just look. So the ones are here, one corresponding to A, one corresponding to B, one corresponding to B, once again one corresponding to C, and so on. So they're taking these from A, which makes perfect sense. A is here, 1, 2, 3, and they are clubbing repetitions. Then 1A and bar. So 1A and bar. Let's just look for that. 1A and bar is here. So it's minus 0.33. So it's just like that here. How about 1B and bar, maybe 1b and bar, 1b and bar minus 0.96. Okay, so it's basically taking values like this. So 1b bar goes here, 1c bar goes here, and so on and so forth. So that makes sense. Now it gives us outline for 1a has this value corresponding to the bar part, and for foo it has that, and so on. Okay. Hmm. I reckon I'll stop here right now, and we'll start with the time series in the next video. I never thought reading documentation would be this fun, because it frankly is. Kudos to the writers for the documentation who made this possible, and thank you guys once again. Consider subscribing, liking, and all that stuff. And as always, I have all the links for very good tutorials in the description. You might want to check them out as well.